The area enclosed by y is equal to x cube, y is equal to 8 and x is equal to 0, which is y-axis, is revolved around the x-axis, and we need to find the volume that is generated as a result using cylindrical shell method. So if I draw this one, I will draw only the first quadrant one. It will look like this. There's also this one, but we don't worry about this part. So this is y is equal to x cube. Then we have y is equal to 8, which is a straight line. Let's say somewhere here, which is y is equal to 8, and then x is equal to 0, which is the y-axis, and this is x-axis, and this enclosed area is revolved around x-axis. We need to find, as a result, a volume is generated, and we need to find that volume. So the first step, let's take a small section here of thickness dy, and let's see when this one is revolved around the x-axis what will be generated. So a cylindrical shell will be generated, something like this, which will have the thickness of dy, and the radius of that, which will be this one, the average, the radius here basically, because this is a very small thickness dy, the radius will be y. So r is y here, this distance, whatever the value of y, that part's y, and the height here is, which is this one, will be of course x. For the shell, this one will be y and this height will be x. So if we think of the surface area of the cylindrical shell of that particular one, it will be this one, 2 pi rh, so 2 pi y times x, and the thickness is dy, so surface area is this much and the volume will be multiplied by dy. So that is the volume of one of the cylindrical shells. Now we need to integrate it from the different, the variable is dy, so we need to integrate from 0 to 8 here. This is 8, this point will be 2 and 8, because y is equal to x cube, so when y is equal to 8, x will be 2. So we need to integrate from 0 to 8, 2 pi will be outside the integration constant, y, and we need to express this x in terms of y, so that will be y to the power 1/3 and then dy. So this is our integration that we have to, this is the expression that we have to integrate. So this one will be 0 to 8 y to the power 4/3 dy, that's 0. So this is now becoming 2 pi here, and y to the power 4/3, so that's becoming 7/3 here, and y to the power 7/3, and this one is 8 here and 0 here. The upper limit is 8, lower limit is 0, so that will be 3 times 3/7, and then this will be 2 to the power that will be 8 to the power 7/3, of course, and then this one is 0, so that will be 0, so we can leave it like that. So this is becoming 6 pi over 7 times 8 can be written as 2 cube, so that will be 2 cube, which will result in 2 to the power 7, because that cube 2 to the power 3 times 7/3, this will go away, so it will this 2 to the power 7 will remain, of course. So this is 6 pi over 7 times 2 to the power 7 is 128. So once the multiplication is done, it will be 768 pi over 7. That will be the volume that is generated, cubic unit. So this is the volume of the cylindrical shell that is generated.